Okay, so here is the notes on chapter 7, and we're going to be talking about confidence intervals. And we're going to start off talking about single population mean. So a Z distribution here. And so let's consider an example. If you recall the histogram from our exams, was not normally distributed because the max score you could get is 100, but you could go all the way down to a score as low as a 0. So we're always going to have that where it's kind of a left tail. So let's do an example of, let's make up a statistics exam. And let's just say the average, the mean is 68. And the standard deviation is 10 here. And we'll say that it's not a normal distribution. So rather than picking one exam, we're going to look at samples of 20 in this case. And therefore, we're going to be looking at the distribution of X bar rather than just X. Okay, so let's go ahead and sketch our little picture. And again, our mean's right in the middle. Here's our distribution of X bar. Here's my standard deviation. And then since we're going to be using the distribution of X bar, we're going to want to find out what that standard error is, which is going to be equal to 10 divided by the square root of 20. So roughly about 2.24. Okay. And so this the mean is what we call a point estimator. And so the goal is to try to kind of get... if someone asks me, well, how did your class do? If I wanted to go all in and just guess on one single number, we would say the point estimator, which in this case is going to be the mean. So 68 here. But we don't always want to just give one value. We'll rather want to give a range of values, or what we call an interval. And this is just going to kind of help us to protect ourselves a little bit when we're being more accurate. You know, if you tell someone, well, what's the price of that calculator? And you're like, it's $120. And if it's not exactly $120, someone's going to say, hey, you didn't get that right. But if I say, oh, the calculator costs between $100 and $140, then that range is going to allow more flexibility for that. So we're going to always not want to go all in and pick a point estimator. We're going to want to pick a range of values here. And so we're going to want to have a lower bound and an upper bound. And that's going to be the interval that we talk about. So a lower end and an upper end. And it's going to be centered around that point estimator, right around the mean there. Okay, and we call the distance from the mean to that upper bound the error. And so we actually have a width of 2 errors there. And so our upper bound is going to be the mean plus the error. And our lower bound is going to be the mean minus the error. And again, note that X bar is an estimate for mu in this case here. All right, so the confidence level here is the probability our interval contains the correct mean. So we're trying to find out is an actual average here. So we want to find out what the actual mean is. And we're just giving a guess. So if I wanted to just give one guess, I would say 68. But I'm going to want to give a range of values. And so we want to see how accurate we are. So I'm giving a guess. And so my confidence level is just a probability that that guess is correct. That my interval actually contains the correct mean somewhere within there. And we usually use a 90% confidence level, 95 or 99. We could use others, but these are the most common ones. And so let's construct a 90% confidence interval for the exam scores here that we just talked about. And so we're going to go ahead and do a 90% confidence interval. And so what that means is that I'm looking at the middle percent there. So whenever we say confidence interval, we don't have to actually say that we're looking at the middle. So there's our 90%. Which means I have 10% left over for the outskirts, and I'll divide that evenly. So 5% and a 5% there. And so this middle region is what I am actually shading here. And so that's going to be my shaded region right up in here. There's my middle part. And my error is actually given by Z alpha half, which is just a Z-score that corresponds to the area on the outskirts here. So let me just finish writing this. And we're going to multiply that by sigma divided by the square root of n, that's standard error. So alpha is the outside area over here. And so there is a specific Z-score that corresponds to this cutoff right there. There's a specific Z-score that corresponds to that. Well, since I had to split my area between the two outside regions, I'm dividing that alpha by 2. So that's where that subscript comes of Z alpha half there. So it's this specific Z-score that we're talking about if we end up talking about the x-axis in terms of Z-scores. So again, so if one side is alpha half there, and so what we're trying to find is that Z-score cutoff, which means we know the area and we're working backwards. So we're going to use the inverse norm, and the area to the left of that first marker is 0.05. We're going to always put 0, 1 when we talk about a standard normal, when we're talking about Z-scores here. Okay. So let me kind of label this here. So in Z-scores, this guy's going to be, if we plug that into our calculator, our inverse norm, it's negative 1.65. Now, we could do the same thing for the other side, where we could do inverse norm of 0.95. That'll be the area to the left of it. However, we know it's symmetric. So whenever we talk about Z-scores, it's always going to be positive and negative. And so our error is that Z-score. So now we're looking at this formula right here, times 10 over the sample, which is 3.7 in that case. So if I wanted to know the upper end, I would go 68 plus that 3.7, and that's where I'm getting that 71.7 there. And then 68 minus 3.7, that's going to give us that 64.3. Whoops. Okay, so I want to talk a little bit right about here. So remember, this x-axis, we could talk about it in terms of two things, in terms of x bar or in terms of Z-scores. So when we talk about it in terms of Z-scores, recall that's the standard normal. So your mean is always going to end up giving you 0, and your standard deviation is always 1 when we talk about it in terms of Z-scores. I'm not going to want to talk about everything in terms of exam scores or heights or inches, whatever my units are, because we're going to want to start using that common measuring stick. And so we're always going to want to talk about things in terms of Z-scores. So we have to start getting familiar with this now. if I pick a specific mark on this graph here, there's three ways of thinking about this. In terms of area to the left of it, in terms of whatever units we're talking about, so in this case it's X bar, or in terms of z-scores. And we're going to want to be able to go back and forth between all three of these values here. So now if someone asks me, how did your class perform? What was the average? Well, I would say the average is going to be between 64.3 and 71.7. And I'm 90% confident that the true average is contained somewhere within there. So I'm now giving an educated guess. Okay, let's look at another example here. So suppose we have some other exam scores here. These guys are normally distributed with an unknown population mean, population standard deviation here. And this is going to be the key thing, that we have an unknown population mean. So in 7.1, we're looking at playing around with the we're looking at unknown population means as opposed to proportions, which we'll get later there. It does say that it's normally distributed, but again, we could still end up using that central limit theorem when we pick samples, regardless if it's normal or not. But we're always going to want to pick samples of this. So let's write down what we know here. So there is your mean of 68 here. So there's our sample mean. Now remember that your X bar is a good estimate for our mu. And there's my sample size of 36, because we're picking groups of 36 here. There we go. And so we're going to be looking at X bar on our x-axis, and then we're going to need the standard error in this case, which is going to be 3 divided by the square root of 36, which is roughly about 0.5 in this case here. All right. And once again, we want the 90% confidence interval. And we always imply when we talk about a confidence interval that we're talking about the middle. All right. So that's our shaded portion there. And we know that's going to account for 90% there, which means that we have left over for our alpha, which is the significance level. We'll talk about that in more detail, but think about it now as the leftover area. And so we're looking for this lower and upper cutoff. That's really what we want to find out. Okay. And so let's go ahead and use the calculator to see how to do this here. So we go under stats, you're going to go over to test, and we're going to scroll down to a Z interval. Okay. So it's going to ask you for your sigma, your X bar, and then your N, and also your confidence level. So my sigma is 3. Notice it's not asking for the standard error. It's going to go ahead and calculate that for you. X bar is going to be 68. And then our N is 36, and we want a 90% confidence level. And if you plug that into your calculator, and I'll put a tutorial up to show you how to do that, it's going to spit out this. And so this is my lower and my upper end in this case here. So Z interval. Okay. This is going to be in substitution of having to plug in all of those other formulas. The calculator is going to work all of that up there. But notice it doesn't give us the standard error and some other things. So we'll be able to actually figure that out backwards there. So let's do some follow-up questions to kind of try to answer all of this. So what if I ask for the point estimator or a point estimate? And that's just going to be X bar, which is 68. So if I had to guess, on one number what I thought the mean was, I would just use the average of them. So that's a good guess there. What is the error here? And if you recall, our actual error was given by that other formula, but since we're using our calculator, what we're going to want to do is use the upper minus the point estimate. So if you recall that this error is centered, or this interval is centered right along the mean. So this distance from here to here is actually my error. And so my error here is going to just be the upper minus the point estimate, which is this guy. So if I subtract those two there, that's going to end up giving me my error. And this is easier because we're using the calculator, so we're just going to kind of work backwards. So I'm getting the value straight from my calculator here, and I'm subtracting that estimate. So that's going to give me 68.822 there, and then let me just label that one. So my error is actually 0.822 in this case. Recall, your interval is the mean plus or minus that error, so that give or take is what we're doing. And let's do one more follow-up question. What is the z-score? What is the z-score for the 90% confidence interval here? So instead of talking about everything in terms of x bar, what would be the value for it as a z-score here? And so that's going to be inverse norm. Area to the left is going to be 0.05 in this case here. So let me see if I could move this real quick right here. There we go. So again, instead of talking about this in terms of the mean, if I talked about this in terms of z-scores, I know that would be 0 right smack in the middle. And so my mu is equal to 0 and my standard deviation is equal to 1 because it's a standard norm. And so the question is, what is this actual z-score? What is this z alpha half right here? And technically that one's negative, and over here I'm going to have a z alpha half that's positive. So that's what I'm looking for. What are those z-scores? And if we plug that in to our calculator, that z alpha half is going to end up giving us 1.65. And notice your calculator will just give you negative 165. But we know it's symmetric, so it's going to be positive and negative in that case there. And then one more question here. Let's interpret the confidence interval because we always want to write it up properly here. And we would say that we are 90% confident the true mean is between 67.178, or we could just say 67.2 and 68.8 in this case here. Okay. And again, just a little note, we typically call this guy the critical values there. So that specific z-score. So now we're reporting information, and we're not sticking to one single value. We're just trying to give a range of values here. Okay, let's do one more example. Here we go. Okay. All right, and I'm just jotting down some of the important stuff here. Okay, so we're looking at a pizza example here. So a pizza delivery, the population standard deviation is 6 minutes, and the sample mean delivery time is 36 minutes, and we took a sample of 20 in this case. And we want a 95% confidence interval. So we want to estimate how long will it take for a pizza to get delivered, right? What's the average range or so, or the average amount there? If we're trying to advertise, your pizza would be delivered in 30 minutes or less, or it's free, we want to first run some statistics to see how long it actually takes us, right? Because we don't want to lose out on a lot of free pizzas here. Okay, so here's all the information we need. All right. And so let's go ahead and do a sketch. Do your confidence interval, point estimate. Go ahead and get the air. And I'll write down a few of these. And you could go ahead and pause this in a bit and then try these guys out. And let's do it more. How about we interpret the confidence interval as well? All right. So if you want to pause it here, try this out, and then I'll come work it out. All right. So here's my sketch. There's my mean in the center. Sigma is 6. The standard error is 6 over 20 here. So my standard error is going to be 1.34. And again, your calculator won't give that to you, so you want to calculate this on your own here. And this time we want the middle 95, which means there's 5% left over, and we're going to divide that by 2. And we're looking at X bar here. There's my lower, there's my upper. Okay, so there's kind of my sketch here. And I'll fill it in a bit further once I calculate some more values. And the confidence interval here, this is what my calculator is going to ask for on the TI. So make sure you plug in whatever you're putting into it. And it's going to just spit out your interval there. Okay. So roughly, if the average is about 36, with that standard deviation of 6 there, that means that the true mean is somewhere within about 33 to 38 or so, right within there. And we're confident, 95% confident in those numbers there. Okay, so that's how we would actually interpret this. We would say that we are 95% confident the true mean delivery time is between roughly about 33.4 minutes and 38.6 minutes. Our point estimator is going to be 36 minutes. Our error is going to be, remember, the upper minus the, which is going to be right here, the upper minus the point estimator. So we're subtracting these two so we could find out that error right up in there here. Okay. And if we talk about it in terms of z-scores, inverse norm. Now, area to the left this time is going to be 0.025 because it's 5%, but we're splitting it by 2. And that's going to give you negative 1.96. But if you recall, it's symmetric. So we know we're going to get a positive as well. And if we're talking z-scores, 0 should be right smack in the middle. Okay, recall, for our standard normal, your mu is 0 and your standard deviation is always 1 in this case. And so that lower end is 33.37, the upper is 38.63 in that case there.